Alright, hello and welcome. Today I was thinking that I should play around a little bit with learning box2d, which is like a physics library that I've been hearing about for some time, and I know it's like, I think it's, yeah, it has been around for a long time, but yeah, I just want to check it out a little bit. And in what better way than to check it out with zig+raylib. So I played around and I got it working now on, well, I haven't actually tried the actual library yet, but I have gotten it to compile at least. So we'll see how we can make it work here. So I have a basic raylib setup here. So if I start this window, if I can get my setup right. Also, I want to set the position, set the window position to 24 by 24 for the string here. I want to do this setup over here actually. Yeah, I also have ECS here, but yeah, that's just to add some sprinkles on top. All right, so actually, do you see this window? No, you don't. So let me get this there. Now you can see that window up and running there. All right, so that is our thing. I'll just change, the background so that we can see that it's working here. All right, so there's our sky blue background. Let's do that dark blue, maybe. I don't know. Sure, fine. All right, so I don't know much about this library. The only thing I know is like it's a physics library, 2D. It has a bunch of features. We could go in here and just look at a bunch of these things happening in here. I'm not sure what this is here. Built in. Oh, this is from the C-lib, standard C-lib. Okay, so we got a bunch of stuff from the standard C-lib, and these are like some helpers. I don't know what it is. We have all the different types defined over here. So this is like taken from, so what I did was I'm running on Zig version 0.16, and then this box2d, I found a wrapper, or not a wrapper, but a library that basically kind of compiles. It's like a compile setup, but for Zig instead of C. So if you look at like the box2d project on GitHub, it only has like, it has CMake, a CMake configuration, but someone made a Zig version of that CMake configuration in principle. So what we have here then is that project that I took. However, it wasn't updated for 0.16. So I had to do a little bit of tinkering to get it to work here, but now we have it working, hopefully here. I mean, I guess we could print out the version to see if you can actually call anything on from this. So actually we can draw it as text here. So let's get like version text. Version text is going to be format print, and this is going to be actually it needs to be print z for raylib, and the buffer is version text buffer. The format is is going to be box2d version. And then we got box2d. Actually, I think they prefaced their stuff with b2, so I'm gonna call the library b2 as well, just to match their thing there. Okay, so get version. That is our text. Oops. Okay, position. Let's just put it somewhere at the top here. Oh, there's some more stuff here. So white, yeah. See if we get this version up here. Okay. Seems that we do have a version here, major, minor, revision. It's kind of hard to see, it's kind of small, but I guess that should be good enough. Can we turn that into some representation or something? No. Okay, well, I guess you could do like this. So b2 version is b2 get version. Major, minor, and revision. So there you can see we're using 3.11, which if I go into box2d GitHub, the latest tag is 3.11, so I guess that is the latest version. Cool. Okay, but I know nothing about how to actually make something in this box2d world, so let's go to box2d yeah, I did a lot of research on how to make how to get this into Zig. Okay, anyway, let's see. So creating a world. So I'm in this box2d. Well, it's 3.1.0 here. Hopefully there's not that many breaking changes. Okay, because I'm on the latest one. Okay, well, it's probably not that many breaking changes. Let's hope. So, creating a world. Every box2d program begins with the creation of a world object. The world is the physics hub that manages memory, object, and simulation. The world is represented by an opaque handle called the B2 world ID. It is easy to create a box2d world. First, create a handle world definition. All right, let's copy this, and I'll just paste it in here. So that should just be straight up like this, and we got our world definition. I'm gonna use the zig what's it called? Convention. That's it. Snake case. Yeah. All right. So we got our little world here. Cool. The world definition is a temporary object that you can create on the stack. Right. Okay. The function default world. Okay. Def populates the world definition with default values. This is necessary because C does not have constructors. I see. So I'm assuming also the helper doesn't really do that, except this is... Oh, I see. This is the helper. Or no. Well, okay. Well, here are the default values. So yeah, I guess this, they're saying that second. Okay, sorry about that. Let's see. Okay, so this is the function that we're talking about. I thought they talked about some other function, but they're saying that if you call this function, you get a thing with all the default stuff. Okay. Cool. But I think in Zig, you could probably just make, you don't really need to call this function. You can just make the struct by calling this, because this has taken all the default values here. I don't know. Maybe it's filling it with other default values. I don't know. Hey, Piano Coder, what's up? Thank you. Good luck yourself. Okay, now I configure the world gravity vector. Note that box2d has no concept of up and up. You may point gravity in any direction you want. Box2d example code uses the positive y-axis as the up direction. Okay, so yeah, we just set gravity here. So world definition, let's make it mutable. Gravity is, and then we can just set it here, x 0, y. Like, it's interesting that they choose, wait, negative, positive. Oh, they're saying the positive y-axis is the up direction, so that's why this goes down. Well, that makes more sense, maybe. Or wait, I don't know, because usually in computer, you know, the computer screen is the pixel. It goes like x goes from left to right, which is same in maths, while y goes from top to bottom, which is reverse from how maths usually does it. So 1 second, I'm just gonna throw out my cat here. Okay, sorry about that. All right, take care, man. Okay, so, well, let's just follow the tutorial for now. So let's just make it like -10 that they have. Now I create a world object. Okay, let's do that. World object. Okay, world ID. So this is, you could, I guess this is like the data that you need to create a world, but you haven't really created it yet, and this is where you actually create the world here. And we get a, wait, okay, so they want a pointer to the struct, and we get an ID back. So I'm guessing, will this do actual side effects like storing the world now? Because yeah, of course it probably has a bunch of internal stuff being stored at some point. The world creation copies all the data it needs out of the world definition, so the world definition is no longer needed. So now we have our physics world. Let's start adding some stuff to it. Okay, well that means we could probably put this in a, function that creates like the world. So let's just get this here. We'll put this in a function, create world, and this gives us a ID, and we'll just return this. So this is like only used here, but this one we actually return, and this thing is just a bunch of IDs here, or yeah, that's a copyable object, so that's fine. So we get our world from create world. Okay, cool. 2D physics, yes. I've never really played around with this, so it's gonna be interesting to see what this, like, how to do things here. Okay, now we have our physics world, so let's start adding some stuff to it. Creating a ground box. Bodies are built using the following steps. Define a body with position, damping, etc. Use the world ID to create a body. Define shapes with friction density, etc. Create shapes on the body. Okay. For step 1, create a ground body. For this, I need a body definition. With the body definition, I specify the initial position of the ground body. Okay. Let's copy this code. So we have a ground body definition, which this gives us here. Cool. And then we set the position to, I think it's like this. For some reason, this was turned into an X and Y like this. Oh, I see. So it is X and Y, but in C, you can kind of shorthand the initialization without specifying the names. I guess it takes like the order of the fields, like a tuple in Zig. Okay, cool. Would be cool if Zig actually had something like that as well. We don't need to specify the type, the number like that though here. So that's good. Okay, so you should be a mutable. Is this a binding or C import? This is, well, C import no longer exists, but it is the same thing. So I'm using a translate C in the build. Well, okay, so the thing is with this here is I'm actually using a bindings. It's not a bindings library. It's a library that fetches the box2d original C implementation, and then it creates essentially like a Zig, like a build configuration that works with Zig. So instead of using the CMake configuration to build a library, then like importing that and make a bindings to it, we actually compile the original source code directly with Zig instead of using CMake. So, but I did have to, it didn't work with 0.16 of Zig, so I had to actually tinker around with box2d, the Zig configuration of the box2d, which is a separate repository. So I had to download, I had to clone that, tinker around with it to make it work with 0.16. But now it works, and you can import it like a module like this, and just import that. But it essentially is using add translate C in the build system. So yeah, there you go. Okay, so we have this ground body definition. All right, step 2, the body definition and world ID are used to create a ground body. Again, the definition is fully copied and may leave scope after body is created. Bodies are static by default. Static bodies don't collide with the other static bodies and are removable by the simulation. Okay. Sounds good. So actually, let's do that. Create ground body. I guess we can have this here. I guess this will give us like a static body, maybe. Body ID. Okay, so this gives you a body ID. And we need a world ID. Well, I'm just gonna call this the world. And then the ground body definition we should move into here. Okay. And then over here we'll get the ground body. we go. Can also make like a struct that does this as well, but for now let's just do it like this. Oh, sorry, I did not. But yeah, I put this in its own function. We create the definition. We set up some stuff. We call create body, which gives us a body ID. We pass in the world ID and a definition, and then we get the ID out. And yeah, then we call this like this. So as they say, like this is on the stack, or yeah, this is on the stack, and when the function is done, we don't need this anymore. So I guess, yeah, we can do it like this. Okay. Maybe you can make bindings if you like it. I mean, we don't really need bindings because I'm just using this. I'm just using the translate C, so it's like automatic bindings, sort of. Yeah, I noticed. Thank you, Blue. I need to really be better at that, or make a better system here. Because when I don't know, when I start to mess around with OBS and like get like alt tabbing to work with which window I'm focusing on, it like starts to crash. So I don't know, but I have a sort of decent system. I need to minimize. I need to remember to minimize the window. Then it like changes the thing. Anyway, or I could just show the window, or the screen, but nah. Anyway, let's continue here. So we have our little ground body now. Notice that the world ID is passed by value. IDs are small structures that should be passed by value. Yes, for step 3, I create a ground polygon. I use that b2 make box to helper to function. Okay, so box, right, box. I was thinking like a 3D box, but I guess this is just a rectangle that is maybe it's like a solid thing. I don't know. I use the b2 make box help function to form the ground polygon into a box shape with the box centered on the origin of the parent body. All right. So can we do this over here? We should probably do this here, I guess. We'll make the box 50 by 10. Okay. Half width, half height. Okay, sure. And this is a polygon. Okay. The makebox function takes half width, half height extents. So in this case, the ground box is 100 units wide and 20 units tall. Box2d is tuned for meters, kilograms, and seconds, so you can consider the extents to be in meters. Box2d generally works best when modules are the size of the typical real-world objects. For example, a barrel is about 1 meter tall. Due to the limitations of floating point arithmetic, using Box2d to model the movement of glaciers or dust particles might not work well. Okay, that's good. That's a good insight. If you want to do some of that simulation, you might not want to use the built-in like Box2d stuff for that. Maybe make a new desktop and show the full screen. Yeah, maybe. I could play around with that at some point. I'll finish the ground body in step 4 by creating a shape. Okay, so now but isn't box a shape? Like, what is a shape though? For this step, I need to create a shape definition which works fine with the default value. Okay, well, let's just do it and see what's gonna happen here. I'll do it in the same thing here since, whoops. Create, so we get a ground shape definition, ground box is a thing we pass in, and then we also have the ID. Okay, so it's gonna connect this ID. Okay, so it's like a shape, create polygon shape, which takes the polygon and creates a shape and ties it to this body, I guess. and you give us something back, but we don't, I guess we don't care about that. Shape ID. Okay, I'm just gonna ignore that then for now. Box2d does not keep a reference to the shape data. It copies the data into the internal data structures. Note that every shape must have a parent body, even shapes that are static. Okay. You may attach multiple shapes to a single parent body. Okay. When you attach a shape, the shape's coordinates become local to the body. Okay. So when the body moves, so does the shape. Okay, cool. A shape's world transform is inherited from the parent body. A shape does not have a transform independent of the body. Okay, so we don't move a shape around on the body. Moving or modifying a shape that is on a body is possible to certain functions, but it should not be part of normal simulation. Okay. Huh. The reason is simple. A body with morphing shapes is not a rigid body, but box2d is a rigid body engine. Many of the algorithms in box2d are based on rigid body model and optimized with that in mind. If this is violated, you may get unexpected behavior. Okay, okay. That's good to know. Good information here. I really like this introduction thing they have here. It's really, yeah, it gives you important information. It's very terse, but it also explains good things. It's not just a wall of text and then some code, like comparing to the Vulkan tutorial. Oh my god, it's like night and day here. Creating a dynamic body. Okay. The thing is though, I mean, I wish now that it would show me how to kind of, okay, how do we get, like, for example, the position and stuff, so we can actually show this body here. But let's see if we can try to fix this ourselves here. So we have the shape ID. Maybe I don't know if we need it, but I guess this because the thing is, like, ground body, do you even have a reference to any of this? Like, can we get the shapes here, for example? Get shapes. Okay. I mean, we know that there's one shape. Body get shapes. Why are there different ones? Is this one like on the struct itself? Okay, so that's just mapped onto the. Oh, does it do automatic? If you follow a certain convention, it actually automatically. Wow. Okay. Wow. Right. Okay. So cool. Because in C you don't have like member functions. So there's no like get shapes function. It's actually just this function. But it recognizes that we have this thing and it just works. Okay. Or it could be something else. I don't know. But yeah, that's cool. Because yeah, but this should all be like generated. We have like the C pointer here and stuff. So yeah, but get shapes, you need like an array and stuff. But I mean, we could just get the shape. So basically like this, I want to do, let's say we draw body and we get the body here. This is a body ID. And let's get the shape. I'm just gonna assume that everything just has one shape. The shape is gonna be one. No, it's just gonna be a shape. Something shape. Shape ID. Is it shape ID? Or what do we get? Set this to undefined. And then we call get shapes. Yeah, it's a shape ID. So this will just do this. that should populate that with the shape, right? And then now we can use it, so we can like call a bunch of shit on here. Now why are these callable as well? Are they also... Huh, this is kind of strange because this is technically not a member function, but it shows up as if it were a member function. Oh, it's like this one here. Are context events enabled? But then it's here as well. I'm confused here. Why would they add multiples of these? That's strange. Okay, well, anyway. Because that pollutes this here a little bit. So how would you get like the extents or something? Shape, polygon, get polygon. Sure, let's assume it's a polygon. So we'll get the polygon. And now we can maybe draw it somehow. Maybe we'll get to this. I'm just gonna continue here. But it also goes on talking about creating a dynamic body. Maybe there's a way, because I wish I could like show this stuff as we go. But we do have the polygon. Count, centroid, normals. Should we just say that, yeah, let's just assume that we just have 4 vertices. I don't know. Hey Polaris, have a nice day yourself. Thank you. Okay. Maybe we'll get to that, simulating the world. So let's skip the dynamic body here. Simulating the world, yeah, that's fine. Clean up, okay. Destroy world. Sure, we can do that, I guess. Destroy world. There we go. Yeah, maybe we could look at, what is this, foundation, collision, simulation, loose end, debug drawing. You can implement the functions in debug draw abstract to get detailed drawing of the box2d world. Debug draw provides a bunch of stuff. This is the preferred method of drawing the box2d simulation rather than accessing data correctly. The reason is that much of the necessary data is internal, subject to change. The samples applications draws the 2D world is using. Okay. Limitations, approximation, simulate rigid bodies. Debug draw. What is happening here? Okay, drawing bounds. Okay, maybe we should look at like one of the samples. Yeah, here's a debug draw. Are they using imgui here? What's this? Yeah, I think they do. Yeah. What is Enki TS? Task scheduler for creating parallel programs. Okay. Well, I mean, okay. I do have. We could look at the actual code. So, whoops. Here is the place where I download the code. This should have like the samples in it. Actually, it doesn't because... Okay, no, it doesn't because it's the other thing. I'm gonna make a new tab. I'm gonna go into zig, pkg, box2d. I'm not sure which one is the newest one. Let's pick you maybe. And you have a bunch of stuff in here, examples. What the hell is this? Is this CMake? Is this this is box2d? Yes. There we go. Here's the box2d, and you have a bunch of samples. So I guess we'll look at car, for example. Oh, is this C++? Yes, it is. Okay. Wait. Main. How are the samples compiled? Is there anything about cars in here? No? Okay, let's look at car. So we have the car, and we have somewhere we should have like... Wait, is box2d a C++ library? Where's the main code? I'm confused. Oh, sample. Here we go. Sample. Bodies. Sample. Is this like the most basic sample here or something? Sample context. What the hell is this? You know what? Let's look at bodies, maybe shapes. Change shape. Where? What? Okay. No. Draw shapes. Sample context. Draw shapes true. Debug draw shapes. Oh. I just don't understand how this debug drawer works. Like, how do you use it? World draw. Like, what's happening in this function? Draw text line. Okay, wait a minute. I think I know, actually, because hello Setu, what's up, what's up? Yeah, for me it's almost nighty night time here. I was just playing around with this here a little bit. So yeah, I think that this thing here, world draw, it kind of relies on some sort of backend, and I think they're using like GLFW, for example. Because we could probably go into the source code and look at like wait. Where is what is this? I'm trying to find like the draw stuff. Shared. Draw. Draw polygon function. Okay. Vertices, verticounts. Okay, so they want you to do this instead of looking at the thing. Because of the internals might change. Color. I mean, I guess it is, could be a nice way to show things, I guess, maybe. I mean, what you also could do is just say that, hey, we could actually make our own thing. I'm just gonna actually pretend I never got in here and not make this general thing. Instead, what I'm gonna do is I'm going to make this draw body. I'm actually gonna say, well, this is gonna be like, let's do this. I'm gonna use like ECS here. So I'm gonna say, okay, let's say we have a ground body. Okay, the ID, so this struct here, what do you actually hold? You hold like a minimal amount of data here. So we can actually store this in ECS if we want. That's fine. It's not gonna change, I don't think, these things. I don't think so. You can use XCB or whatever. I don't know what that is. I'm also doing something similar. I'm porting C++ code. Okay, cool. So what I'm gonna do is I'm just gonna create ground body entity, and we're gonna add to this entity, we're gonna add the ground body ID. And well, actually, you know what? Let's do this here actually. So let's put the registry here as well. So we'll create the entity. So we'll return the entity actually instead, because the entity is going to hold the ID in it. So we just need to get that there. So there we go. So there's our entity. Now we do make this kind of box here. And so I'm thinking that let's say we make, well, this box is like 50 by 100, right? So this box can be, well, it has all these weird stuff. So what we could do is we could just make our own kind of version here, add it as kind of like a renderable or something, and that will be what we can render that. So I'm just gonna make this easy for me here. So I'll just make a box renderable, and this will be, actually let's do this. Let's do a renderable, which is a union enum, and let's make a box, which is a box, and then we'll make a box is a struct, and you have, yeah, let's do like extents is a vector. So let's just use Rayleigh vector, I guess, for convenience here. And yeah, that's what we have for now. Okay, and then we can also have like, it could also include like color as well, and then we can make a draw function here. So let's make this draw function, and we'll draw a rectangle. Actually, we also need a position as well. So there we go, position. Actually, I think we need like PRO here actually, because it needs like origin and stuff. So we have a rectangle, the rectangle. So position is position X, position Y, width is self extends X. I guess we have to like do ×2 here, because that's what it was. And then origin is extends, it just extends. Rotation, color, I guess, rotation, man, that should be something. Actually, we could pass in rotation here. Yeah, and then color is self color. That's the ID. Do you want the registry? I'm just gonna do this. We don't really need to actually grab it out. Okay, so then what we do is we add this renderable to groundbot thing. You are a box, and I'll just add a convenience init function here as well, which gives us a box, and you want the extends and the color. Okay. Now what you also can do here is we can make a generic draw function, which is a renderable. And you can do a switch. If you have a union enum, you do a switch self and then inline else. We get the thing underneath that we call draw from there. So that will actually be sort of like a generic draw function, which will call the draw function of whatever subtype we have. But let's create this thing here. So I'm going to say extents is going to be a vector 2, 50 by 10, and so we have extents x, extents, sorry, y. Okay, and then you are going to be the extents, and then the color, I'm just going to say white here. Oops. Porting C++ code is really annoying. Oh, really? Whoops, extends, yes. Okay, so now we should be having this renderable. Now we want a function that is like draw. And we get our registry, and we get our view, which is going to be a view of everything that has a renderable. The thing is also, like, the body itself probably, yeah, we need like, I think we need like body ID as well. So let's make our iterator here, and then while we get an entity, we can loop through all those. And so here we get our body is going to be view get body ID from entity, and we get our renderable. And then we're just gonna call draw. Also, that's right, we need the position and rotation. So this is going to be, I guess, can we get the position? Yes, we can. Okay, and you're just X and Y, right? So this is the thing, like this is an X and Y. The thing is, it's probably exactly the same as the Raylib vector, but we still have to kind of convert it. Maybe we can just say, we can just cast, like bit cast. I'm gonna try it. Maybe it will work, maybe not. Rotation. It's a struct. C and S. What the hell is this? Degrees. Can we get radians? Angle. Okay, let's just hope that's the angle that we need. Okay. So there we go. Now we're going through all the bodies, and we're calling draw, and we get the position and angle. Hopefully this is all we need to draw these boxes here. Now I do realize that this is going to be a lot of work if we want to support every possible thing that, like, we are not like supporting arbitrary polygons and stuff like that, but At least we're just drawing like this box now. We could even add like rectangle lines if we want as well, but that's gonna be more, yeah, that's gonna be more difficult because we can't supply an origin, but we can calculate the origin ourselves, of course. But anyway, we should be able to draw this now if we call draw over here. So let's call draw before the text. So there we go. Let's see if, okay, you, all right, you need excludes as well. See how it works. Okay, so I'm not seeing anything. Did it fall down or something? Also, the simulation is not like, I'm not stepping through the simulation, so I'm not sure if that makes it so that it doesn't spawn or something like that. But the thing is, well, it probably has spawned actually. I mean, it does, the data should be there, and we're drawing, I mean, the thing that we have should be in the ECS system, and we should have our renderable with our box. The position is probably something. So let's actually log out position. I'm just gonna say adding here, so it will just log that out. And okay, so it's actually like 0, -10. Okay, yeah. Actually, you know what? I think, yeah, the issue is that we're kind of assuming that we are like 0, 0 is the center of the screen, I think. So what we're gonna do is I'm gonna create a raylib camera that we are going to add into, actually let's just add it into the singletons. And raylib camera 2D. And we will set offset, target, and rotation and zoom. Okay, so these are the standards. Now the thing is, like offset and target, one of these we are going to change to be the center of the screen. So I'm going to set screen size is going to be vector 2 init 720 by 720. I think you are comp times friendly, so yes. Screen size X, screen size Y. Okay. Now what did I think about? Yeah. So either offset or target needs to be changed. I'm thinking offset is probably what we want to change. So I'm gonna say screen size scale half. So that will probably put now the thing on into the middle, or is like should be negative maybe. Let's see. Well, okay, I forgot about a thing as well. We need to also do begin mode 2D with this camera. Problem is we don't have the camera. Actually, we don't need to add it as a singleton. Let's just add the camera like this for now. We can add it as a singleton later, but for now we just need to actually pass this in over here, and then when we're done drawing, we do end mode 2D. There we go. So hopefully, okay, there we go. Now we get this thing there. So if we now enable, well, okay, let's get the dynamic body in now. So let's go back to here, and we'll go back to the hello here, dynamic body. So let's continue with this now. Now that we can actually show the things we can continue here. Okay, creating a dynamic body. I can use the same technique to create a dynamic body. The main difference besides dimensions is that I must establish the dynamics body's mass properties. First, I create the body using create body. By default, bodies are static, so I should set b2 body type at creation type to make the body dynamic. I should also use the body definition to put the body at the intended position for simulation. Creating a body and then moving it afterwards is very inefficient and may cause lag spikes, especially if many bodies are created at origin. Makes a lot of sense. Okay, let's copy this code. Oh, there's a convenient copy button here. And I guess we'll put this in here, like create dynamic body. And we're gonna need a registry to be able to register it in our ECS, to be able to draw it. And we'll also need the world as well. Okay, and I will get an entity out. Oops, and here is the start of this thing. Your body def. You are going to be dynamic now. B2 body type. CU int. Oh, it's like a proper C dynamic or a C enum here. So there we go. I wish it would wait, or did I do this? I'd have to be using an enum, right? Because the enums exist, I'm pretty sure. Yeah, okay, well, whatever. Position is 0, 0. So 0, 0. Do you actually have an init function or something? No. And then we get the ID and by creating it, pass in the thing. Okay, there we go. Great. And let's also create the entity, which we return at the end. Okay, and then the entity is gonna get the body ID, and we're also gonna add. Well, we're gonna see what we need here, but now we have the thing there at least. We're gonna add, like, I guess, like shapes and stuff as well. Caution, you must set the body type to dynamic body if you want the body to move in response to forces. Makes a lot of sense. Okay, thank you for that. Next, I create and attach a polygon shape using a shape definition. First, I create another box shape. Let's do that. So we have our box. I'm just gonna call it box, which is 1 by 1. Interesting. Okay. And so we have that. Next, I create a shape definition for the box. Notice that I set density to 1. The default density is 1, so this is unnecessary. Also, the friction of the surface material is set to 0.3. And from what I've learned from physics, essentially density 1 kind of means it's like a human density. So the density of a human, I believe, is like 1 or something like that. So, or like a water, or no way. Yeah, anyway. So this is unnecessary. Also, the friction of the surface material set to 0.3. Okay, interesting. Yes, now we get some stuff happening there. So we have our shape definition. Let's conventionalize that. Set density to 1 because we can. Actually, default is 0 here. So that's actually good, because I think the density 0 might lead to some issues. Okay, 0.3. Cool. Okay, okay. We call this function, so the default value should be 1 if they say it's 1 from this function. So this is the default. I guess this is like, maybe zig translate C has like defaults for the converted structs. So every number is set to 0, maybe. I don't know. Okay, everything is set to 0 essentially, I guess. Friction, yeah, cool. So there we have our shape definition. You don't take anything? No, okay. So caution, a dynamic body should have at least one shape with a non-zero density, otherwise you will get a strange behavior. Okay, good to know. Using the shape definition, I can now create the shape. This automatically updates the mass of the body. You can add as many shapes as you like to a body. Each one contributes to the total mass. All right, cool. So let's do that. We need the body ID, shape definition, and the box. Great, so that should, I think you return something here. Yeah, shape ID, which we don't care about apparently. But that gives us, that should be done now. Yeah, so that's it for the installation. Now we're ready to begin simulating. So let's get this thing be shown first here. So since we added the box of 1, 1, I want to also do like extents here, and 1, 1, and actually you should be extents X, extents Y. And I do want to, like, I recognize that this is a pattern now here that we are doing, so there's not much difference between ground body and dynamic body here, so a lot of things can be, you know, broken out here, but whatever, I'm just gonna do this here for now. So we add a renderable, sorry, and you are going to be also a box that we init, and we put the extents in there, and the color, I guess we could put you to be red or green maybe. Okay, now I saw that this is also the incorrect typing, so there we go, spelling, sorry. Okay, so there we should now have a dynamic body that we can, well, okay, we have to call it here as well, dynamic body. There we go. Did it actually change the position? Yes, it changed the position to 0, 0. So in their mind, that means above. Right, but actually Raylib is gonna, this is gonna be pretty funny, because I think Raylib is gonna draw this the other way around. Cannot assign to constant. Okay, yeah, there we go. Okay, when I see it, it's like on top of the it's very, very tiny. So actually, let's zoom in a little bit. Let's zoom in like by 4 or something, so we can see it. Okay, there we go. It's like almost in the other. So okay, there we go. We have our ground, and we have our little dynamic body below here. So now next step is, I'm actually going to change that to yellow because it's easier to see, or maybe even red, because then it's going to be easier to see both from the white and from the blue. There we go. There's a little red body there, and now we're going to see what's going to happen if we start to simulate this world here. And yeah, it's gonna be interesting to see what's gonna happen here. So, simulating the world. I've initialized the ground box and a dynamic box. Now we are ready to set Newton loose to do his thing. I just have a couple more issues to consider. Okay, box2d uses a computational algorithm called an integrator. Integrators simulate the physics equation at discrete points in time. This goes along with a traditional game loop where we essentially have a flip book of movement on the screen. So we need to pick a time step for box2d. Generally fixes engines for games like a time step at least as fast as 60 Hz or 1/68th of seconds. You can get away with larger time steps, but you will have to be careful about setting up your simulation. It is also not good for the time step to vary from frame to frame. A variable time step produces variable results, which makes it difficult to debug. So don't tie the time step to your frame rate. Without further ado, here is the time step. Time step is 1/60. Right, but with Raylib you can set a target FPS, but I'm not sure if if the FPS drops lower or is like variable at some point. It's I think it doesn't do like a fixed update for you. I don't think so. I might be wrong on that. But I have, like in my game, other game, I actually had to implement my own like fixed update thing. But I guess we'll just follow this tutorial and see how this works here. So let's get this time step thing here. So we'll have a time step. Okay, that's 1/60. Which is okay, so it's okay, 16 milliseconds, 16.7 roundabout milliseconds. Okay, so 60 FPS. In addition to the integrator, box2d also uses a larger bit of code called a constraint solver. Wow, many big words here. The constraint solver solves all the constraints in the simulation. You don't say. One at a time. Okay, a single constraint can be solved perfectly. However, when box2d solves one constraint, it slightly disrupts other constraints. To get a good solution, box2d needs to iterate over all constraints a number of times. box2d uses substepping as a means of constraint iteration. It lets the simulation move forward in time by small amounts. Each constraint gets a chance to react to the changes. The suggested substep count for box2d is 4. You can tune this number to your liking. Just keep in mind that this has a trade-off between performance and accuracy. Using fewer substeps increases performance, but accuracy suffers. Likewise, using the more substeps decreases performance, but improves the quality of your simulation. For this example, I will use 4 substeps. Yeah. Okay, sure. 4 substeps. Let's go. Substeps. Substep count is 4. Fine. And note that the time step and the substep count are related. As the time step decreases, the size of the substep also decreases. For example, a 60 Hz time step and 4 substeps. If substeps operate at 240 Hz with 8 substeps, the substep is 480 Hz. We are now ready to begin the simulation loop. In your game, the simulation loop can be merged with your game loop. Right. In each pass through your game loop, you call world step. Just one call is usually enough. Depending on your frame rate and your fixed time step, I recommend this article. Fix your time step to run your game simulation at a fixed rate. The Hello World test was designed to be simple, so it has no graphical output. The code prints out the position and rotation. Okay, so we simply call this world step here then. Hello, Pactorap. What's up, what's up? Just a guess, but it sounds as if they apply, you should not tie animation to frame rate because they do not render into discrete frames per se, but some movement may be spread across frames. Yeah, no problem. Yeah, so I think what they mean is basically, so this is the same that I did in my game. It's like the physics engine the updates happen at a fixed interval of, you know, let's say 10. If we have 100 FPS, it happens at a fixed update rate of 10 milliseconds. Like each 10 milliseconds, you will update the physics, basically. So the physics update is happening every 10 milliseconds, essentially. And after 10, or wait, yeah, and after 100 of those, that's 1 second, right? So that's 100 frames per second. So, but then you have like the other frame, like the other kind of frame update that happens essentially as fast as it can, which usually happens a lot more. Like those frames are, there's a lot more of those frames that happens than the fixed update frame. So there's like two kinds of frames. You have the fixed update frame, which is the one that where the physics update, and then you have the frame where that just runs as fast as it can. And in the one that runs as fast as it can, I usually put things like, well, I've heard that it's good to put like input, like reading input in that, because otherwise it can feel like it's lagging, because the input should be read like instantly, while the actual physics update is happening at fixed intervals. And the drawing, I mean, you can try to say, I guess you can try to, I mean, I guess that's what's happening in most like libraries or the hardware or whatever. It's syncing the drawing to the frame rate as well. So something like that anyway. So but yeah, I think that's what they mean. That's what they're talking about. So let's do after we draw. No, before we draw. Sorry, before we draw, we do an update. We do the step. Now this is not a fixed update yet. You can set a target FPS to 60 here. So this would be the target FPS. I can also say FPS is 60. And we can just replace all that. So, but I don't think it's guaranteed that this will be a fixed update step, is what I'm trying to say. So this loop here is not guaranteed to be 60 FPS, like a fixed time step. But it will get, like, it helps a little bit all along the way. So I'm not going to implement a true fixed update here. I'm just going to use this set target FPS for this. Time step and substep count. Okay, cool. So now we should be simulating the world. Okay, cool. And nothing's happening. You might wonder, like, why isn't the thing like falling down? Because I think it's, you know, because it's like reversed, right? Now the question is, can you nudge this thing? Like, if let's say I put the dynamic body, can you add velocity here? Okay, let's say x is 1. What happens if now we have like initial kind of velocity? Okay, I guess it could have been like friction. Let's set like y equals 10. That should go upwards, right? So it's kind of like it should jump now a little bit. It's not doing that. Okay. What if we put you at 10? What's going to happen then? Oh, it's just stuck. Okay, so maybe this step doesn't work yet for some reason. Wait, you're F64. This should be working. If I set you should be comp time float, yes. F32 can't represent value. Okay, wait, but you're F64, right? Oh, okay, so this is F32. There we go. What's it? Okay, there we go. Now we get some simulation here. Boom. Interesting. It works. So now we have physics. And there we go. Let's put this back to 0. I'm just gonna see what happens here because they are kind of inside it. Like the red one is like on top of the other one, so it's gonna get like pushed out. I'm pretty sure. Yeah, we're seeing it kind of adjust and getting pushed out. Okay, I wonder. Yeah. So now the thing is, let's change the gravity to be the other way around because yeah, that's what makes more sense to me. Like the Y position should be like negative should be upwards and positive is downwards. So if we run this now, this thing should fall down to the bottom of the screen. There we go. Goodbye. Okay, cool. So there we go. We have our little simulation there. Let's try and let's do this. Let's make this a little bit more generic. So let's have a position. And we'll have a maybe, I mean, we could pass in like velocity. You can also pass in a bunch of stuff. Density, material friction, like there's a lot of things. But let's just pass in position and size for now. Or size, not size, but let's do extents, I guess, to make it easier. Maybe to think about. Alright, so that's our extents. So we could just remove that. And the position is just going to be like bitcast position. Cool. I wonder if you even need to bitcast that, actually, to be honest. Like, let's, like, if we do this, will it be an error? I think it will. Extents was 1 by 1. Yeah. So we need to bitcast this. It's essentially the same struct, so we can just bitcast. I don't think bitcast does that even have, that shouldn't have any cost. Okay. Now what I want to do is I want to make it so that when I click let's see, let's do like 3 by 3 or 5 by 5 maybe. Let's do this. So when I click, I'm just gonna drop a random thing. So let's have an update happening over here. So if is mouse pressed, then we'll create a thing. So create dynamic body. Oh yeah, we need a world. Let's just pass in the world here, fine. Position. So the position is going to be the mouse position. Extents is this going to be like default extents or whatever. Okay, so now whenever we click the button, okay, whenever we click the button, the dynamic body will be created. Okay, or not. Did I call? Yeah, I'm calling the function. The left mouse button is press the position. Oh yeah, because this is okay. This is not. We need to convert the position into. So basically, if I click up here, this should correspond to the center. Yeah. So I need to convert the mouse position into world coordinates. So there's like screen position or coordinates or something. Screen to world. So get mouse position and the world. Oh, now we actually do need the camera in here. So let's see. Let's do singletons add. And the camera is actually we should probably get it here. Get const camera 2D. Blues, what registry view does in ECS also registers just structure of arrays. So yeah, the registry is basically holding all the data in the ECS system. Like if you create an entity, it's gonna hold that. And then you can attach a bunch of components. So if you attach a component, like what we're doing up here, or I mean down here. So basically add, you get an entity and then some kind of data. Now this data can be anything. And what it's going to do is it's going to create space for that data in the registry. So it's basically taking ownership also kind of over this data. But this is just an ID though. So since this exists both in box2d and here, it's good that it's just an ID. It doesn't actually hold any like data that's going to be dynamic, like it's static data. It's just an ID. So, but that's what's happening here. So also here we add a renderable. This renderable is also, you know, we pass in data here. Then this data is gonna be there's gonna be a pointer created in the registry when we call this to store this data in there. And to get it later, we have to have the entity. Or iterate through everything that has a renderable, basically. And that's what we're doing with a view then. So when we draw, we get a view of every entity that has both a body ID and a renderable. So all the entities that have both of these things are going to be targets of this view. We get an iterator so that we can iterate through all the entities that satisfy these conditions here. And then we can grab out this data using the view get. So we can get the body ID, we can also get the renderable, and then we just use that data to do whatever we want with. Factor app. Follow-up question. More thinking out loud actually. 2 different FPS for logic versus render implies tearing or not. Okay, VSync ain't possible unless we have 2 fixed and use GCD. Yeah, I'm not sure. I just know that for what I'm doing for my game, I don't remember where I put the draw actually. But yeah, it makes sense to put it in a fixed update since we don't need to draw like every time. We just need to draw when we are supposed to draw. So I don't know. I don't know if it actually draws, you know, every time you call draw, or if it just sets up the draw to execute the draw whenever another frame hits or something like that. I don't know actually. But I think they probably use something like a buffer that So if you can't manage to update the frame, I guess in time, it will use like the previous commands to render the thing. I don't know. I actually don't know exactly how it works, but then you wouldn't get tearing, but you would get some frames that are like potentially like 1 frame old, essentially. But that doesn't really make sense though. I don't know. Anyway, maybe, I don't know if that's how the way it works or however it works, but I've never seen any tearing in Raylib when using Raylib, so yeah. Okay, so this is the position. Okay. Actually, I think if you can't manage in time, it would actually just skip a frame, actually, because then it looks like it's lagging, actually. So that's what's happening. Okay, there we go. Now I can press this and get a bunch of boxes on here. And you can see they are simulated. They even have the rotation, although the rotation looks weird. I think I know why. The reason why is because Raylib, man, I almost said Angular for some reason. Raylib, because I was thinking about angles, uses degrees in some areas instead of the normal way to use radians. So we actually have to convert this into degrees, which you do by saying times 180 over pi. So there we go. Okay, that looks a lot better now. So we can create a bunch of boxes, and yay, we have our kind of, you know, box2d demo application here working for us. And we can spawn boxes wherever we want, and they will kind of push other boxes away. Man, let's actually, let's draw some FPS here. Let's draw it, I don't know, screen size, no. Let's draw it, maybe, I was thinking like down, yeah, okay, screen size, no, X should be like 8 or something, and then here should be screen size, Y minus, I don't know, 16. How big is this gonna be drawing at? And then you are a vector, you are a F32, so we need to do like int from float. Now we should have, yeah, no, random color per spawn. Yeah, we could do that. The FPS is down here, so 60 FPS. How much can we get? Adding a whole bunch of stuff. I don't think I can get it down. Okay, well, what if we just increase the ground? The quest for nuking FPS. Let's do like 24. Also, I want to change this to like, I don't know, dark purple. No, sure, because you can't really see the FPS very well there. Okay, and then the boxes, or let's just do black, why not? And then let's do boxes, or no, you're white, but you, the ground body, is light gray, and but you are going to be positioned at like screen size y over no minus extents y times 2. Okay, so it should be at the bottom now. Yeah. Oh yeah, we're zooming in, that's right. We're zooming in. So it should be like over 4. I guess we'll increase this a little bit. What the hell? Over 4, which should be like, I don't know, whatever we have. Okay, fine. Let's just add up. Let's just do it manually. Let's do like 100. How do I structure my code? Do I put all the components in one file and system in other files? What if I have multiple levels? Yeah, that is something you. That is a very, very. I don't know. It's just something you will have to learn over time. I mean, I don't know. You kind of build up an intuition of how you are doing it. It's different from project to project. Like I usually like when I start up a project, it just starts up, and so I just do it. It just happens naturally, basically. So when you start a project, there's really no reason to start organizing the first thing you do. Like the first thing you do is just get something up, something that works. That's usually how I work, and then like you know, as the project grows, you can kind of see where the patterns lead you to, you know, how you should organize it, essentially. And then you get better and better at seeing those patterns and over time. And so it's really not really a question you need to ask, is what I'm gonna say, because it's gonna just it's just how you decide to organize it, essentially, I guess. So, but the question is, yes, you should organize your code, but it's not as important like when you start out a new project. It becomes more important the more the project grows, is I'm gonna say. Why is this not showing up at all now? Okay. Oh yeah, I think it should be like screen, wait, no. Screen size over 2, so over 8. That should be at the bottom. There we go. And then we take minus extends y. Actually, just minus extends y once, because we're already halfway up. There we go. Now we're at the bottom. Because I was thinking, yeah, we need to divide by 2 since we're zoomed in kind of the bottom half. Yeah, anyway. So there we go. Now I'm going to change you to maybe 5, and you're going to be increased to maybe 200. Okay, so now we have a ground like this. Cool. Now, yeah, the random color. So let's put a color here so we can pass in whatever color we want. And let's see. Right, so we need like a random color. The thing about random is that you need like IO for that. So I'm gonna have to, well, you can either pass in, I guess we can pass in the registry, or we could pass in IO. I guess, yeah, let's do IO here. Do you have IO? No, you don't. Get const IO. There we go. Okay, so I'm gonna say like the pool of colors is gonna be an array of colors, and it's just gonna be like, I don't know, blue, green, red, yellow, purple. What do we have? Cyan? No, there's no cyan, right? Lime, maroon, pink, orange, pink, maroon. Yeah, that's enough. Or brown. Yeah. Okay. So to get a random, first you get a random index. Actually, first we need a random instance. So that is going to be like random IO something something IO source. So there we go. Now we have the random instance there, and then you say like random interface, and then uint. Now we have, this is the thing that you can actually use to get random numbers. So to get an index, you do like uint less than usize, and then colors length. There we go. So now we get a random index of colors, and then we just return one of those colors. So there we go. Now we have the return type is a color. There we go. Cool. So now we should have random colors for our thing. Oh yeah, wait. It's gonna crash if I attempt to do this because we haven't added the standard IO to our singletons. So I will go up to our singleton stuff, and I will add init.io, which is the built-in sort of juicy main IO that we get for free. Okay, there we go. Now we have a bunch of random colors. Let's see if we can get the FPS down here. How much? That's a lot of stuff. Maybe it can't. I don't know. Yeah, no problem, Blue. You can ask as much as you want. How to use allocators in ECS? So, I mean, it depends on what you want to do. The registry, if you're using this library, the registry has like the allocator that you pass in to create the registry. It has a it saves it on the struct, so you can just say reg.allocator and you can access it. Okay, I don't seem to be able to. Yeah. Oh, 59. No. Okay. I don't know. Yeah, that Yeah, I can lock it on a higher number. Yeah, that's true. That's true. But that also means that the time step is gonna change as well. So that will. But yeah, let's do like 300, I guess, or maybe 1,000. Oh, actually, I saw it already go down. Maybe. I mean, it's kind of stuck at. Now there we go. It goes down a little bit, but then now it went up again for some reason. It's struggling. It is struggling, but it is keeping within its like capacity here, I guess. Oh man. Okay, well we can. Okay, there we go. There we go. There we go. Well, I mean, it is kind of impressive. Also, now you have to realize also that the number of updates that's happening is way more. So, yeah, you have to keep that in mind. Okay, cool. Let's do 100, I guess. Well, that was actually a lot easier than I thought it would be. I was kind of scared of this to start with, but it's actually another physics engine I was looking at was called Bullet, I think. And that one might be a bit more tricky, I don't know, to set up. I've heard some scary stories about some of these system or physics engines, but this was pretty simple. I mean, this is the most simplest example that you can set up. We could look at another sample and try to kind of mimic what's going on there. I'm just gonna refill my water glass here. I'll be right back. All right. Now make Angry Bird, yeah. That's the thing about these systems. Now we can play around. I've never actually done this, like getting like these kinds of systems and played around with making some kind of simple game with them. Okay, so was there anything else here? I don't think so. Yeah, this is showing like you have the position and the rotation, and it's showing all that stuff. Okay, cool. So we have things, I don't know what this is, foundations, vector math, okay, so assertions, allocation, version, multi-threading, multiple worlds. Wow. Cool. Okay, we have collisions. Right, so if you wanna raycast, shapecast. Cool. Ghost collisions. I mean, actually, technically, we should be able to make a Doom clone with this, because Doom is like technically sort of 2D in its nature, so you can use like a 2D collision detection library for making a Doom clone. Yeah, and then there's things like chains and stuff like that. Dynamic tree. Okay, it's using a dynamic tree. Cool. Simulation, ID, world lifetime. Right, it's just destroying it. Simulation. Yeah, rigid bodies. Okay, yeah, there's a lot of stuff you can do here. Gravity scale, damping, position angle, body type. Is there only like dynamic and static? Kinematic? What is the difference then between kinematic and dynamic? Okay, static body, zero mass, zero velocity, may manually be moved. Kinematic body, zero mass, velocity set by user, moved by solver. So, okay, dynamic body has mass, so kinematic cannot actually collide, is that what you're saying? But it can still move. So it could be used for things like particles and stuff like that? Maybe? I don't know. Because then it could be kind of more efficient, maybe, for stuff like that. Position angle damping, reduce world velocity of bodies, friction. So it's kind of like air drag or something. Damping parameter non-negative. Sleep. What does sleep mean? Expensive to simulate, so unless we simulate better. But when a body comes to rest, we should stop simulating it. Right. Okay. This is where it gets tricky if something that should wake up doesn't. If a body is awake and collides with a sleeping body, then a sleeping body wakes up. Bodies will also wake up if a joint or contact attached to them is destroyed. Okay, cool. Kinematic if it's player and dynamic is for NPC. I mean, doesn't that depend on how you want it to work? Like, if you want the player to be able to push other things in a physics simulation, wouldn't you want the player to also be dynamic? The is awake flag is ignored if enable sleep is false. Fixed rotation bullets. Wait, bullets? Huh. So is it just because it's like very fast? Okay. Game simulation usually generates a sequence of transforms that are played at some frame rate. This is called discrete simulation. In discrete simulation, rigid bodies can move by a large amount in one time step. If a physics engine doesn't account for a large motion, you may see some objects incorrectly pass through each other. This effect is called tunneling. Oh, so it doesn't actually simulate. Well, it doesn't do the sub steps, I guess. Uh, for that then. By default, I mean, so then either you can increase the number of sub steps to not have that happen, or, well, a very fast thing is gonna drag that simulation down if you want to simulate it perfectly. By default, box2d uses continuous collision detection. Okay, there we go. To prevent dynamics from tunneling through static bodies. This is done by sweeping shapes. Okay, there we go. The engine looks for new collisions during sweep and computes the time of impact. So these bodies are moved to their first. Okay, there we go. Yeah, that's that. Okay, now that makes more sense than what I said. Normally, SSD is not used between dynamic bodies. This is done to keep performance reasonable. In some game scenarios, you need dynamic bodies to use SSD. For example, you might want to shoot a high-speed bullet at a stack of dynamic bricks. Without SSD, the bullet might tunnel through. Okay, so things can tunnel through dynamic stuff, but not through static. I see. Fast-moving objects, unless you mark it like a bullet. But you have to also consider. You can essentially set everything to bullet. It just increases the. It's kind of like a weird. Is bullet. Is that really what you're saying? Like, does it have other things happening as well when you set it to bullet? Or is it only that you enable CCD for dynamic bodies? Because that's probably what it should be called, maybe. I don't know. Bullet, I mean, it kind of makes sense from a game dev, like, maybe perspective to call it is bullet. I don't know. Fast moving objects can be considered as bullets, posed to perform CCD, but all with all body types, but not other bullets. Oh, so that's also special then. Okay. You should decide what bodies should be bullets based on our game design. If you decide a body should be treated as a bullet, use the following setting. Okay. This library is so fun. Yeah, it seems very cool. How did you get it working? Okay. Well, okay. Quick recap. Yeah. So I did go over this before a little bit, but essentially, so this project I'm using raylib zig. I'm using zig ECS and box2d, but the caveat here is that since I'm using zig 0.16, the box2d project was not actually updated yet to work with 0.16. So what I had to do was essentially modify and tinker with that to convert it into how a C. So basically, what changed from 0.16, or I mean from previously 0.16 to 0.16, is how you import a C module or a C project. So, oh, sorry. Thank you, Blue. Yeah, I mean, I'm just showing the dependencies here. So the box2d project. Okay, let me actually open that up because I have it over here. So I clone down this from what is it? Get URL? No. Remote. Get URL. So I clone this down from this. All your code base / box2d. This is kind of like a repository that seems to. I didn't know about it before, but it's like it's apparently Zig. It turns a bunch of stuff to work with Zig, basically. Yeah, and so I cloned this down because it wasn't updated for 0.16, but I made it work now. So what I did was that I had to call this function add translate C instead of how it was before. And this is actually good because the previous version, you actually had to make a C file and import that, or you had to, like if you want to use this library, you had to either make a C file and import that, or you had to make a C import statement in your code. However, how it works now is that this is just exported as a module, as a Zig module. So you can just import it as a normal Zig module, and you don't even know that it's a C library. So from a user standpoint of using this library, it's actually much more convenient to use this library now. And yeah, it just looks like any other Zig library. But we have to change how we export it. So before, they created a module like this. So they had like, yeah, mod is like add module. So they added a module called like box2d mod, and then they added a bunch of stuff to this module. The problem was that I couldn't use this module to import in my project because it didn't work for some reason. I don't think so anyway. Maybe it did because I had some other issues with it that I had to export a new file and stuff. I had to export this root file, which I had to add here as well. This essentially just includes box2d the header files. So that's what that's the root source file of this one, which is add translate C. I mean, I could probably, I don't know. Well, this is probably good here. So you do this now, add translate C, and then the rest is basically the same, except the mod is created from taking the translate C thing and saying add module from that instead of creating a new module from scratch. Okay, and then you have to add an include path and the source files. This is taken from what it was before. And then I have this add library thing. I'm not sure if you need this, but I have it there. That was there before. And then all of this was basically, I'm just testing a bunch of stuff. And I added like a testing. But anyway, that's what I had to do to get this to work. And I spent a bunch of time trying to get this to work, but it finally did work. Okay. So you can, like, if you want to do this now, you can't. Unless you tinker it with what I did. So sorry about that, but yeah. And I've seen like a couple of pull requests on this project, but they've been up since like January, so I'm not sure about the maintenance. I mean, I guess I could put up a fork of this that works. But yeah, anyway. So there you go. There's your box2d, and we have ECS Raylib, the usual stuff here. And then I have, you know, this is like the default module that comes with when you zig in it. So I just added these over there, and then we can import them over here, and we have box2d. I'm using Raylib here to create a window. We have our ECS registry created. I'm printing out the box2d version. And here we create our box2d stuff, the world. And yeah, this is just me following here's just me following basically the world, or the box2d hello world example, essentially. And that's essentially it here. Then I also added a way to render these boxes. Very simple things. Okay, but why did you pick this lib? I don't know. It just popped up in my mind. I've seen it before. I was just curious to test it out. I mean, there's a lot of different physics engines, and I never really, you know, went into and tried to use one, really. So I just wanted to see, like, I saw this box2d configuration to build with Zig, so I thought, hey, okay, let's try this and we'll see. First, I tried to just import it using just importing it normally, like a C project, but the problem was that it had this special configuration and stuff, so I didn't really understand how to convert the CMake configuration into a proper Zig configuration. But I did see someone who said that if you have a CMake project, you can essentially just very easily actually create a build step that builds that project. However, then you will get like a shared library or something. You will get like, you have to kind of link it in and then still, you know, create a bunch of external functions, something like that. How did you add physics to an entity? Okay, so this is how it works. The physics simulation is not happening in the ECS system. The ECS system doesn't actually have the position data or anything like that. Position data and rotation data and everything in the physics is part of the box2d library that manages that. So when we create a body here, so first you create a world in box2d to be able to store a bunch of bodies in. Okay, then you create then you can create bodies on it. And so you create these body definitions, you create a body on the thing. Now we have a body in the world. And then you can add like shapes and stuff to it so that it actually has like some sort of shape on it. Like this is a box here. And then what I put in in the ACS register here is I put the ID of the body, so we can kind of, you know, we can see which body it is, so we can use that to get data from the box2d system, like position and rotation. And then I add this how to render, basically information about how to render this body. And then when I draw the thing, we get the body like the body ID from the entity, and we get like information about how to render it, and then we get the position and the rotation from the body. So that is data that's that we get from the box2d library system. And then when we draw, I simply call this box draw function. This is gonna call, you know, draw, and we have the position, we have the rotation, and then we also store the information about, you know, what shape it is here. So this is a box, and we're just drawing it, you know, as it is here. So what I did was basically the box2d has position, rotation, all the physics stuff. The ECS system just has an ID to that body, so we can get that information. And then it also has information on how to draw the body. Okay, so, and that's like, if we wanna, let's say we wanna draw a circle, but you can probably add like a circle shape instead. Like if, let's say we have, this is the, I mean, let's say this is a polygon, whatever it is. I don't really know what the hell it is. You can make an ABV, offset, box, polygon, proxy, I don't know what that is, rot, what the hell is that? Rounded box, square. Wait, aren't there like circles? Circle, collide circles, compute circle, create circle shape. Cast circle. Is it compute, like create circle shape? Is that the thing? Okay, so we have to create a circle, I guess. That has a center and a radius. Okay, I see. So actually, right, so you could do that as well. And what you could do is you could say, well, let's just make this maybe we should, actually what you could do is you could have a shape enum, and this is a box or a circle. So we're gonna support boxes and circles. I can put shape here. So now I have to implement circle. Yeah, and we can also create, or we can also say, you know, make whatever polygon we need to have for this. So create polygon, or wait, is that really gonna be the polygon? Because it's a circle. Circle, create circle shape. This creates this gives a shape or a polygon. It creates a shape directly. So this is different then. But anyway, yeah, so maybe we should get a shape out and not a other thing. actually. So basically create shape, okay? This gives us a shape ID. And we have our shape here. The thing is though, this should probably also be, actually let's call this a shape type box or circle. You are union enum. So because I want, or union shape type, because I want the information about how big is the box, for example. We want like the extents, so this would be vector2. This is, I'm just gonna grab this circle here because it has the things we need. Okay, and if we do this, if it's a box, so we can switch on self. If we have a box, then we get the extents out, and we can create our box, and we can do whatever we need over here. Although this also wants this, we also need a shape definition. So actually, let's put the shape definition over here as well. Shape def. And we'll return create shape or whatever it's called, polygon shape, body ID. So we need the body ID as well, and we need the definition. It's going to be shape definition. Polygon is the box. There we go. Isn't it traditional easiest to attach physics component to an entity? I need to study one. I mean, in this case, it's like I'm using a physics engine which kind of handles all the data itself. And in that case, it makes more sense if I'm gonna use an ECS. It like the box2d system doesn't know about my ECS library, so it's like I'm using ECS on top of this. And in this case, it makes more sense to just do it like this because, yeah, there's no way of, you know, storing the data somewhere else. Like box2d is managing the data and everything like that. And I think, yeah, that's usually, you know, unless you're implementing the engine yourself, the physics engine yourself, this is sort of how you have to do it, I guess. You know, we need the body ID. This is the body ID. There we go. And then we have circle. Circle def. And this is just create circle shape. Body ID, shape definition, and circle. Let's just call it circle. Okay, so there we go. So now we can create both circles and boxes. Over here, instead of doing this, we are going to say we're going to create our shape, which is going to be shape dot, well, it's going to be a box. And the box is extents. There we go. And then we don't really, well, we can create a shape def, and we can say shape dot create shape body ID, and then shape def. We just pass in shape def there. So there we go. And then that's it. We create the shape. Actually, yeah. So there we go. And then the thing is over here, we get a renderable. The thing is, yeah, then we can also use the shape now to create the renderable as well. So create renderable. Though we don't really need these. We need the registry. No, we don't need the registry. We just, well, if we wanna add it to the entity, I guess we could do it here. But actually, I'm just gonna return a renderable here. If we have a box, then we simply return well, let's we return. Well, let's return from here instead. Maybe we return a renderable dot box. Actually, we don't need to specify that because that's already implied. And the box is as extends. Actually, we could probably just put the shape here. Maybe. I don't know. Let's do it like this. And then color is color. We should pass in color here as well. Okay. And then circle is same thing, except this one is a circle. And I guess we have a radius. Actually, why is there a center for the circle? That's weird. Because that's like an offset. They just said that we probably don't have a center for things. Like an offset for shapes. Alright, good night, Blue. When I use raylib texture and stuff, I don't add it either, just use separate in systems. I mean, it depends. Like ECS, it could be used as a way to store the data. I'm just gonna copy radius and see if that works here. Yeah, it's just that center could be anchored. The thing is, like, the documentation said that usually shapes are centered around the body origin. So they are, if like, it's not meant to be used as a way to kind of put a thing together with a bunch of different offsets, I guess. Because if you want to put a multi-body thing in, you're gonna have to use, I guess, like connections for that or something like that, if you want to build a car, let's say. So that's why I'm surprised that the circle has a center. But okay, whatever. Color is color. I'm just not gonna use center here and just assume it's gonna be 0 for everything. So there we go. Now we can go down here and we can say, well, instead of creating this renderable, we're just gonna say shape create renderable and give it the color that we want to have. And so now, instead of saying extents, we can pass in a shape instead, and that is now what we are going to use. So there we go. So now we can actually create circles or boxes here. So there we go. We need to implement drawing a circle though. So let's create a circle here. And we'll create our circle struct. This is going to have radius and the color. And then init function. Oh yeah, we can just use in.init here. Why do I always type extends? Oops. yeah, draw circle doesn't have a draw function. You need to be circle. You are returning a circle. And rotation for a circle doesn't really matter unless we're drawing a texture. I guess we'll put in rotation so that we can see. Maybe we'll draw like a line where the rotation is out to the radius. Okay, so instead of drawing a rectangle, we're gonna draw a circle. Let's do circle V. Center is position. Radius is radius. Color is color. And there we go. That's that's it. Let's draw. We could draw a line from position to line end with what color would this be? I guess let's just do green. And the line end is going to be position add my first thought it might be used internally to check applied forces since it's used modules. Yeah, it might be that it's not actually used when creating the thing, like when creating the shape, but I don't know. Let's see. So the end of the line should be position plus. So like. Let's say we go to the right and we rotate. Okay. It's a shame you can't do that. Right, rotate, and then the angle. Now the question is, I'm not sure if this angle is supposed to be radians or not, but we'll find out. So rotate, rotation, and when they have to scale by the radius. Okay, because radius is half of the circle width. Yeah, and you shouldn't even be here. There we go. Value type ignored. Yeah. Cool. See if this still compiles and everything. Okay, I need to actually be able to do this. Okay, yeah. So now let's do like if I press, so if I press like right mouse button, I will create a circle instead with center. Are you automatically set to something? You are set to 0, 0. Cool. So we should only be worrying ourselves with radius here. Radius, I guess we'll put it to 1, maybe. No, actually, I want it to be default X. So it has the same kind of size as the. Okay, and there we go. Here's a bunch of circles, and you can see kind of the green line points towards the rotation. So there we go. That works. Cool. Now we have circles. Okay, can we build a car now? If we connect two things. Oh man, you get thirsty when it's warm. I need to actually go to sleep soon here. But this is fun. Okay. Should we try to do? I mean, let's look at an example, and we can see maybe what's happening. Oh, did we get a? Oh, I thought we got a raid. Usually when I see new people, we usually get a raid. Hello, GUI Sai? GUI Sai? Like GUI, like graphical user interface? Or is it pronounced something else? Welcome. Zig, yes. Yes, definitely. Where, okay, the example, well, we had the example over here. No, not over here. Actually, we had them over here. It was one of these. Here we go. Samples. Although I'm not exactly sure how they work. I began to learn Zig yesterday. I did some Zig links. Nice. Felt weird about not having private fields or structs. I mean, I think that's a good thing. I think it's good that you, especially as a user of something, it's really nice to be able to change whatever you want. If it just feels like you have total control, total freedom, just use it responsibly. Wait, I just saw the circles you push in, aka spawn on top, are actually popped in the back behind the new tile. So it is 3D but simplified. Or the center for Z effect, Z index might actually be correct. I don't know. I think the thing is, it's I'm rendering with raylib. That's the thing. So it depends on which order I'm rendering the things. So if we go to draw here, we're looping through each entity, and I'm drawing it in a certain order. The order is probably just in the order that I add them. So the one that I'm adding is probably going to end up on top of the next one. Or, okay, well, behind, I guess. That actually doesn't make sense. The new one should be actually on top. It's always behind. Missing constructor. I see your, I mean, are you coming from C++ or something, some other class-based language? C++ Java, okay. I love OOP, okay. Well, I don't think I've ever heard anyone say that. No, I'm just kidding. But yeah, I don't know what to say. You should try other things. I mean, OOP has its uses, but it has been kind of overdone a little bit in, I mean, just like multiple inheritance. I don't think anyone thinks that's a good idea. It's Uno reverse. Yeah, it's weird. It's like it's looping through them reverse. I mean, this is just how ECS goes through each entity. Yeah, so that's what's happening there. Okay. What the hell are we doing now? Yeah. So I want to check out. I mean, there's a thing called car. So let's check that out. We have car. Here we go. Here's some C++ for you. Okay. Right. C++ with void star. Yes. I mean, it's just a sample. Okay, so we spawn a car. So this puts a bunch of vertices here. It's modifying them a little bit, I guess. B2 is null. I mean, we're not gonna see what that is. This is also the problem with C++ and C, is that you have some kind of function here, but you have no idea where it comes from unless you're using some kind of ID that like loads in everything. I guess that's what people use. I don't know. Or they just, I guess, I don't know. But I mean, I don't like it if I'm including some stuff and all of a sudden my global scope has all these like invisible symbols. I don't like that. I do enjoy error as a type thing. Error as value, yes. That is very, very, very good. I really love that. Although it's probably one of the... I mean, for me, it's not that big of a deal, I don't think. I mean, it's good. It's very visible that something can error and what errors it can have. So that is a very, very nice thing. And then because also then you can have some logic based around what kind of error you get. Sometimes it is actually used to, you know, you're supposed to look at the error and decide what to do based on what the error you get, especially when you have like file reading from a file and then you have, there's actually a stream end error that you have to sometimes handle however you want. Okay, well, anyway, so we have a hull compute, B2 compute hull vertices. Okay, so that is apparently some kind of thing. And then you can make a polygon from that. So the hull is just a vertices. And then the polygon is furthering that. Okay, and then... Okay, but this is all things we already sort of have. We have a circle. We have... what are we making here? Are you even... It's just the car. Yeah. We have the body different dynamic. We add position. We set position here. We have a... We create the... I think this is the chassis. We added chassis shape. The circle is not even used here. It could be moved down. Okay, I should stop that. Shape, or is it used here? I don't think so. No, it's used down there. Okay. Well, I guess they are creating stuff up here. Anyway, shape definition density. Well, are they changing the shape definition after they used it already? Okay, so they're reusing this shape definition. Very, very optimal here. So they're changing the density, friction, rolling resist. So they're making the wheels, I guess. Fast rotation, true, okay. Maybe that we need that for wheels. And here we create the rear wheel, create circle shape. And then we change the position a little bit, allow fast rotation, and we create the second wheel. Okay, there we go. And then we have a pivot. Well, that's the axis and the pivot. So here we can see, okay, here we go. Joint def. joint definition. I mean, essentially, we could just copy all of this code actually, and have this, you know, just be our car spawn thing. So let's copy this code, and I'm actually gonna make a new file because there's so much stuff in here. So create car. I guess we could create, well, no, let's not return anything. I do want my registry. No, that's not what I want. And probably B2. Yeah. So we want the registry, we want the world. Also, yeah, we should import this car thing. Car.zig. Cool. Now we have all these things. World ID. No. B2 world ID. Thank you. All right. So we have a bunch of vertices. Let's remove all the F's from here. And you need to be dots. Actually, you know what? I'm just gonna create a macro here. Space. No. Okay, there's probably a way more efficient way to do this. Create a macro, insert this. Remove the F. And you need .x, .y. Oops. I moved down once. Okay, there we go. So there we go. There's our vertices. And you are 6. This is also the good thing about Zig. You can do this, and then you can say P2 vec. And then these are now, wait, no, like this. Yeah. So now this is a thing with 6. It automatically counted the number of things, and you can then use the length here. So there we go. Except this is just length I. Or since we're actually just want to modify these, we can just say vertices vertex vertex.x vertex.y. And there we go. What is scale? Oh, it's from here. Did I didn't copy this. Okay, so I can explain this here. So basically, this loops through the array. If I want to mutate the array, I have to add the address here And then this will make the vertex a pointer. It's not dereferencing. It's making it a pointer. If I remove this, it's just gonna be a copy now. That's also constant, so you can't actually change these. But now it's mutable. So essentially, you can think of it as star means mutable, not star means not mutable, and constant as well. Didn't learn that in Zeglings. Oh, really? Yeah. There's probably a bunch of stuff. Why do we need scale? I mean, I guess let's just do this. Scale equals 1. There we go. There's your scale. All right, so we have a hull. We have a polygon. Most of this code is, you know, we can just pass through. Vertices is an array, but since it's need to be a pointer, I have to do this, I believe. Shape definition. All the F's can F off. I'll do 1.0 there so we don't get some weird... actually, let's do 1.0 there, because then it becomes a floating comtime float, because sometimes when you divide like comtime int with a comtime int, it actually truncates it, so you don't get the real value. The circle is a B2 circle. Did you actually not need to put the type there? What the hell is this? Oh, because the type is there. Oh my, okay. Yeah. Yes. Great. Good. Okay. But you are not the thing we have. It's this one. And you are the center, which we don't actually need to set because it's already 0, but we do want to set the radius to that. Body definition. Oops. We don't really need to do this though. I mean, do we really want to use B2 add for this? I wish. Position is where we want to create it, right? So let's add position here as a Raylib vector, and then we can just say position.add 0, 1 times scale. Okay, so basically scale. Wait, was that really what you said? Yes. Okay. And then we have the chassis ID. No, wait. Where do you come from? What the hell is this? Oh, it's a member. It's a field. Okay. Do we really need to store that? Okay, I guess we'll make a core struct. And I'm not following this stupid convention. Sorry. The ID is body ID, I think. I think the reason why they want this convention M underscore is just because of how the language is. Like, the members are just invisibly available at all times. instead of saying self dot blah blah blah, you just say, you have to, so M makes it clear that, okay, it's a member. So now I finally understand why this is even a thing. Like this pattern here is even a thing at all. No syntax highlighter thing. What do you mean? You are a body ID. Okay, so I guess let's make this car here. I guess we'll just set it to undefined or something for now. Or we'll create it later. And we'll just say that chassis ID is equal to this. No, actually, let's keep the name. And we'll rename it later. Syntax highlighter and tell you this line is broken. Yeah, so I disabled that because I don't want to be distracted with a bunch of red squiggly lines and errors popping up every time I type. So now I decide when I want to check the error. So I'm checking my error and it's like, yeah, I don't care about this right now. I'm over here trying to figure this out now. So it's just to not get distracted, because I'm very, very easily distracted. World ID is just world. Okay. We create this thing. Good. Okay, we set a bunch of stuff. Here, same thing here. We do like position, add scale, and 35 times scale. Okay, also we need to bitcast these. I just realized. Okay. You are going to be there we go, you're just world. Then we create that. Position and bitcast minute 1 or scale and 0.4 times scale. All right. So axis and pivot are b2 vec, body get position. I mean, we never changed position. Shouldn't we just be able to get the, I guess, whatever. We have the rear wheel ID get position. We could just do that. There we go. Okay. Okay, and here we create, here's how you create a joint, I guess. I mean, it's just that it's so much stuff you have to put in here, and that's the thing. But it's good and bad, I guess. Yeah, so B2 body, this is the joint def body ID A, get local vector of axis. This is body ID A, get local point, pivot. It's good because you can define a bunch of different things. And you can essentially create your own thing you want. Damping ratio scale. So why not just, we need all of these. There we go. Oh yeah, dot x, y. Okay. Here, the axle. So what is this then? Rear axle ID, wheel joint. So there's an actual like special wheel joint. Interesting. It feels like it's almost made for these demo applications where you're like driving these cars around. Wait. This was defined before, so they want it to be mutable. Sure, why not? Why not? And then front wheel ID, get position. Okay, same thing here. Joint def for the IDA, get local vector. Wait, axis. Joint def. For the IDA, get local point pivot. For the IDB, get local point pivot. Front axle ID. Okay. Yes, so now we get a bunch of these. And now let's make a car. We have chassis ID. We have a bunch of these things. I guess throttle is not used. Speed. Okay, rear axle. Let's call it, whoops, rear axle ID. Actually, let's just call it without IDs. That's, yeah. We have front axle. All right. I guess, yeah, we can return this car actually. Car, there we go. Let's just return this. Yeah, okay, cool. So, that's the one thing left. Let's do this for now. Cool. So now we can create a car. The only thing is we don't create the shapes and all that. So what I'm gonna do is I'm going to create kind of like a box2d sort of library here. Or maybe we can actually, let's make, no, god damn it. Let's make like shape. No. Yeah, so take everything here. I'm gonna put you over there. And renderable, we'll put Okay. Now let's go to... Oh, you need renderable. Circular dependency, but that's fine. Now let's go to root and we can grab a shape. Actually needs to be public as well. And renderable. Okay, are we still running? Yes. Dig, 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 dig. Cool. Now create dynamic body. Create. Yeah. Okay. Sure. Let's do box2d. I will move these functions over there. Yes. No. Create world. Actually, let's call this b2l for lib. Create world is over here. It's not called, not marked public. There we go. All right. Cool. 95 lines in this file now. Good. What's your issue? Why are you this way? Raylib. There we go. Screen size. Oh, okay. Well, let's make a config. And we'll put you in the config. Now everyone can enjoy the screen size. All right, renderable. Shape. Cool. RL. There we go. Check this again. Great. All right. Cool. So now let's see. We can create the car. So what I wanted to do here is I wanted to well, here's the circle body definition. What I wanted to do was create a polygon shape. I basically wanted... Actually, this is different because this is a polygon. It's not actually like it's not a box. So I'm gonna skip that for now. I'm just gonna draw the wheels actually. because we don't have like a polygon. Well, actually, draw there is a polylines, but is there a poly? Oh, there is. Oh, we can draw this maybe. Why? Uh, draw a regular polygon. Okay. Is there a way to draw like, you know, a polygon that's filled with arbitrary vertices? I mean, you can draw a bunch of lines, but then to fill it is another thing. Model wires, no, that's 3D stuff. Polylines, that's not the same. It's just very, very simple things here. Spline, no. Is it spline linear? Does that fill though? I don't know. Segment? No. Okay. But we can do the circles. So we can do like circle shape. So this is like rear circle shape is shape. Let's import shape dot circle, and the radius is something. Oops, it's gonna be this guy. That's the circle we want. So actually we could just pass that here. Okay, there's our shape. And then we can basically, we could just create the shape here. We don't need, and then the shape definition is shape def. We don't need to do that. We create this shape here. We can actually just create it over here. And then you can just be defined like this is that we actually, this is the wheel shape. Oops. Okay. Same thing here. Instead of creating that, we're gonna do wheel shape, create shape, front wheel, shape, definition. There we go. So that should create those shapes, but we also need to create we also need to do the renderables. So we're gonna create the rear wheel entity is register create, and we need to add the ID, and then we also need to add the wheel shape create renderable, and the color, I guess, dark gray. Okay, there we go. Now let's do it for the front wheel as well. There we go. Although you should be the front wheel. There we go. Cool. So that should make it so that we can see the wheels, but we can't see the chassis. But that's gonna be good enough for now. Because yeah, we would need some kind of polygon line. I mean, we could draw the like the outline maybe of the vertices or something like that. But yeah, let's do it like this for now, and I'm gonna call it after this. I'm also gonna have to make the car movable so we can actually drive the car, I think. But let's try to get it working here to start with. So I'm gonna import, well, we already have car. Okay. So let's make the car. Where do we create the world and all this? Over here. Okay. So let's create the car here. Car, create the car. Registry, world. Position is, let's just do 0, 0. So it will just spawn in the center. That's gonna be fine. Okay. We should create the car now. Vertex. Oh, this needs to be mutable. There we go. Off-topic question: have you shared your toolchain dev ID setup anywhere, somewhere? I don't think I have. Also, you need to be mutable. I think I've answered like some comments, but I mean, essentially, so I'm on Windows, right? Windows is my host operating system, and then this development environment is running under WSL, which is a Linux virtual machine, sort of the official way to do it with Windows. And I'm running Ubuntu, I think version 22 or something like that, something distribution. And the terminal kind of emulator or whatever is the it's called WezTerm, WEZ term for Windows. Yeah, I mean that's basically, and then NeoVim. The config is available, but it's not really meant to be used by other people than me, essentially. So it is available on my GitHub, so it's like a public repository. You can go in and check for, just look for nvim config. And but yeah, as I said, it's not really meant to be used like as a, you know, anyone can go in and clone it and it's gonna work. It's like, it has a tiny bit of setup required for it to work. I just have it because I sometimes, you know, if I switch, you know, work, if I want to install it on my work machine or something like that, I have to kind of, you know, redo all the NeoVim settings. So I created a repository where I can just clone it down and do some stuff to make it work again. But yeah, so I made like a rudimentary, super simple script to do that stuff, but it's really not that great. Polygon shape, like the shapes we don't care about. There we go. Yeah, we don't care about these shapes here. Joint def is not immutable. Okay. You want, oh, you're a joint ID, not a body ID. I see. Joint ID. Okay, fine. Now let's call this by some more simple names. Okay, cool. Yeah. let's call that the polygon instead. There we go. Okay, so can we run this now? Do we get a car? Oh my god, we get something. Okay, it looked like it worked, but it was kind of tiny. Let's do like 5. Huh. Why are they oriented like that? Did I do something wrong with... Okay, let's do 10. Also, they seem to be like... Why are they starting at the same position? Did I do something wrong here? We'll check it out. Yeah, use GUI X Nix Native Windows 11 Enterprise plus Mac OS. So I'm always interested in flow style. It can be applied cross-platform. Okay, cool. Yeah, I really like Westterm. You can. It has a config in Lua that you can configure like startup things and stuff. And it works pretty cool, pretty well. Although one thing it doesn't have is like the thing where you can have like images in the terminal. It doesn't have that, but I've gotten used to it. So, and it doesn't have like fancy. I don't think it has like fancy like shaders and stuff like that. But I don't really care about that stuff. So I just want things to work, so I can work. That sounded so boring, but yeah. Okay, wow, time really flies. It's 20 past 1 right now here, AM. I just want to make this car work here. How come this is so bad? Why is it the Y position is like the one that's changing? I don't understand this. This is weird. Like, also why? No, wait, it's not. This is -1, right? Okay, scale -1. Okay, so this should be negative scale. But why is the other one? Why is it different? Why? Why? Position, add position. Yeah, why is this 0.4 and this 0.35? That's weird. Okay, there we go. There's our car. And you can see... Oh, is it upside down? It's upside down. Position of the chassis. So let's do negative scale. Also, all the Y positions need to be inverted, so there we go. I think that should do it. It's kind of hard to tell because the car is not... Okay, interesting. So there is kind of like a weird friction thing going on with the wheels, but okay, cool. That seems to work. It's kind of weird that we can't actually see the car, but whatever. Let's see if we can make it go somehow. So let's make a function. Well, I guess we'll check how they do it. So we have like set speed, we have set torque, set hertz. Huh, damping ratio, truck. Wait, they have a different... They have a truck as well. So Where do they... Joints, maybe this is where they have the car. Yeah, here they have the car. Okay, they spawn the car. Spring hurts. So here you can kind of set the different things through sliders. If we press A, we're setting the speed. Okay, so the speed changes the thing. And then why? Oh, the camera follows the car, I see. But what is happening here? Oh, we're just showing it. Okay. Cool. So we just need to change the speed, I guess. So agree, Wisdom is nifty. True cross-platform modern basic term. I switched to it for cross-platform because it also runs on FreeBSD and Illum OS besides the majors. A phosphor CRT shader. Oh. Does it have shaders? I'm asking for a friend. Well, I just ranted that I don't care about that stuff. But yeah. Okay, so let's call this, let's do like, I don't know, car, let's do like, well, actually, let's put a function on the car itself, actually. Set speed. This is gonna be the car. Do we need like world and stuff? I don't think we need. Like chassis. Wait, okay, so let's see what this is actually doing here. Set speed. Set motor speed. Okay. So it's like rear axle, set motor speed. I guess it's an F32, yeah. Okay, and then front axle, set motor speed. And then rear axle, wake bodies. Okay, sure. There we go. And now we can go to our main thing here. We can go to update. And let's check the code for the thing. I'm gonna copy this. And we'll do if is key down. A little simpler. And this is S. And this is okay. Then the car, which we should... Wait, what the hell? Where's this coming from? Driving? Oh. Okay, so it's just a thing down there. Okay. Cool. So throttle is like, so okay, so what the hell is this used for? Set speed. So okay, so it's setting the speed every frame or something like that here. Update, yeah. But it only does like when does it set the speed otherwise? I don't understand. Because here it doesn't use throttle. But this is only when the slider changes, I think. So I'm confused. It's like the algorithm is different whether you use this or you press the key. Okay, I'm confused. Let's just forget about this throttle thing, and let's just set the speed directly here. The speed is set to what, 35? Sure. As far as I know, it doesn't have shaders yet. Okay, I have to use retro term or terminology enlightenment for the retro effect. Okay, cool. So we don't care about this throttle. The car is, well, technically we could just pass the car in here. Let's call this car module. Okay. No. Car set speed. And the speed is going to be, I'm just gonna say car mod car speed for now. There we go. So now we should be able to change that. Set speed. Okay, let's call you new speed. There we go. And you need the car. So let's pass the car. Except we don't have the car because we discard it. So let's grab it. All right. Now let's see if we can control this thing. Oh, it crashed. Interesting. First crash with this here. Is illegal instruction. Interesting. Okay, car 16. Set motor speed to new speed. We create the car. The car is then copied over when we do this. It shouldn't change, like the car IDs, like these IDs. They shouldn't change, right? Or do they actually change? How do we keep up with that? Because we are using the ID to understand which one we are looking at, right? So this should be a stable thing we should be able to use, right? And copy. I'm pretty sure. so there should be no issues with copying the card because it's only a bunch of IDs. But yeah, illegal instruction. Box2d assertion joint type equals type. Did I? Okay, this might be. No, joint type. Like I was thinking if it was a version mismatch thing where, but no, because these are from the samples. Okay, body, chassis. Motor speed. I guess that's the current speed then. I'm just checking if I made a mistake here somewhere. So yeah, here we're creating the wheels. Because what I'm thinking is this error is coming from, like box2d is coming from here, this assertion here, where joint type is equal to some kind of type. And this comes from joint.c. I mean, we can go and look at actually this, the source code here. Whoops. Joint C 134. Yeah, so it fails here. Joint type. So that is something that we don't see. Types. Okay, so it's supposed to be a wheel joint, I guess. I mean, we don't really change this here. Okay, so then, I mean, this could be an issue with the mapping, maybe. Get joint sim check type. Okay, it fails as soon as I try to change the speed. in any direction. So I tried all 3 buttons and it crashes on all of them. So I'm gonna think that create wheel joint should create that joint type, right? B2 wheel joint should be the type, yeah. Now motor joint, wheel joint, is there like set speed here? No. Where is set speed then? Huh. I mean, I could go in here and search. I have to kind of do this. Oh, wait, what? No. Oops. Oh, set motor speed. It's called set motor speed. Okay. It's a wheel joint. Okay. So I'm gonna guess here that I'm picking the wrong thing. This one, it says that this is going for a joint ID. But actually we want like a wheel joint. Oh, I think I know what's going on. Is this because this is like inherited? Oh, why is it like this? This might be something else. Oh, that's the sim. Okay. So, okay, I think I know what's going on. So we have this joint. This joint type, right? Where is this coming from? Probably joint.h. Okay, we have this B2 joint somewhere. Yeah, this is the joint. Okay, and then we have like wheel. Oh, maybe that's we have like wheel joint. Yeah, here. No, this is just a struct. What the hell? Okay, well, okay, I don't know. I don't know. Why do we get then? So shouldn't this be a wheel joint? There is no wheel joint ID. This is confusing actually, because the actual source code has different structs. Create wheel joint. Gives us a joint. Oh, so it does give us a normal joint. Okay. Okay. And then this is like a union here. Okay, I see. Or something. I don't know. Okay, so we do have joint IDs, but we want to do like wheel joint set speed. Okay. Because otherwise it's gonna do set, it's gonna just do set motor speed, but it has to be the correct thing. Okay, so set motor speed has like a bunch of different ones. Then you have to use the correct one. Okay. Well, great. And now we should be using the correct one here. Okay, well, it doesn't crash at least. Okay, so I'm trying to do stuff. It's not really responding. Okay, well, the car is reacting to other things. Do I need to scale the speed? M speed 35. Wait, did I set it to 35? Yeah, it's 35. ASD, yeah. Okay, I can see it actually does move. It's just very slow. Let's just increase the speed, I guess. Maybe it should be scaled by scale. I don't know. Also, it's like reversed. Let's just do 35 times scale. Still very slow. Okay, maybe I should adjust other stuff. like torque and things. Maybe mass of the chassis or something. Density 2 over scale. Right. 1 over scale. Torque. Hertz damping. I guess we'll increase. Let's do that. What the hell? What am I missing? Hello, said who? Love writing com interface wrappers by hand. That sounds like a nice time. Okay, let's make this ridiculous number up here. There's like nothing's happening. I'm not even sure if I'm actually accelerating anything here by pressing the buttons. Rear axle set motor speed. Front axle set motor speed. Wake body's rear axle. What is torque to start with? 5. So these are all the defaults that we already had. I mean, okay. So they kind of hinted also that if you put in whatever it is, like the scale, like maybe scale shouldn't be too much here. I mean, the car should be like, maybe this is already, if scale 1, if this is meters, maybe it's already complete, but this looks too small to be. No, wait, it goes from negative 1.15 to plus 1.5, or negative 1.5 to plus 1.5. That's 3 meters. Yeah, actually, let's just go to scale 1. And see if we can actually move this at all. Okay, now things are happening. Oh, it fell over. Let's go to root and we will zoom in. Let's actually do, I don't know, 20. I wanna wait, where? No, box2d, here we go. Yeah, this thing. So it's gonna be negative, so over 2 times, oh yeah, we need zoom in config actually. Okay. So the ground should be at the same place, hopefully. Yes. We're zooming in. Now I can drive. Although it's like the other way around for some reason. So I'll change it. Also, let's zoom in a little bit more. Like this. It's like submerging from the thing. Okay, and then also what we could do is we could update the camera to follow the car actually. So let's get the camera. Oops. And we'll set the target to be get position. What else gonna be? Chassis get position. Oh. There we go. So now the camera should always follow the car. Okay. Unless it's like reversed, then we need to... No, that works. So now we don't really see it actually moving around, but if we add some stuff here, oh, we need to actually... Yeah, we can see that we actually are driving around here. Cool. Now... let's change you to like 0.05 maybe. Oh, that was way too small. 0.5, that's half a meter. Yeah, you can see the car kind of outline is... Man, it's such a weak car. Let's put some circles on here. All right. Cool. So we have our little car. Oh, I see. If I release the button, oh yeah, first off, I want to change these around. So this should actually be negative and this is positive. Oh yeah, S is brake. There we go. If I press right and let go, it still keeps accelerating. So it's kind of like when I release, it doesn't actually stop. So let's have like, if we press any of these, if we don't press any button, we also set the speed to 0. It's kind of like braking almost. Not really, right? It doesn't really brake. It's more like it just makes the friction happen. Yeah. So now... This is way too much friction, to be honest, for a realistic car. At least I don't get a mail, that's what I tell myself. Yeah. Me too, man. Can you make a seesaw plank type demo to different weights, so heavy weight launches up to lightweight? Well, not now, not today. I have to go to sleep now. It's 2 o'clock in the night. But we have this little car thing going around. We can make these shapes and we can push things around, and yeah, that's box2d for you. And yeah, it would be cool to actually draw the car as well, like, yeah, but yeah, that's gonna be it for this time. Maybe next time we'll check out another one, like I don't know. We'll see what happens, but we'll probably, yeah, I don't know, we'll see. But yeah, thank you very much for watching, and